Hello, everyone. So I was sort of taking a sneak peek at the work that had already been submitted for these titration problems that I assigned yesterday. And I'm noticing that some of you are confused as to what you're supposed to do. Some of you have been able to solve the problems, but the work looks a little bit jumbled, and I'm not exactly sure if you're clear on what you're doing. I noticed that some of you are using the approach that was shown in the Khan Academy video, which is perfectly valid. But it also happens to not be my preferred approach. And so I thought I would share with you how I would solve the first couple of problems on this assignment in the hopes that basically you'll be able to follow suit and solve the rest of the problems on the sheet. So let's have a look at number one. Basically, for number one, they want us to find the molar mass of lactic acid. And we're being told that this lactic acid is being titrated with 0.206 molar sodium hydroxide, and they ended up using 31.11 milliliters of sodium hydroxide to titrate the lactic acid. And what I've noticed is a few of you, what you did is you realized, well, okay, they didn't give me the formula for lactic acid, and so it's possible you guys probably went and Googled lactic acid and found the molar mass that way and try to incorporate it in your solution, but that really isn't necessary. You can't actually calculate the molar mass of the lactic acid just with the information you've been given. So allow me to sort of underscore how these solution stoichiometry problems are supposed to work. It is absolutely critical that you go and you actually get to the point where you can use the mole ratio from the balanced chemical equation to actually solve the problem. That's true of any stoichiometry problem, so this is critical. So what that means is when you're provided the data, so we were given 0.578 grams of lactic acid, we were given the concentration of the base, and we were given the volume of the base used, you have to find a way to work your way into units of moles. Notice we're not there yet anywhere. Basically, none of these numbers are in units of moles, so we can't even do this yet. And you have to choose the path that will get you to moles. Only one possible path will exist. Like notice, if we had the molar mass of lactic acid, I could convert the grams of lactic acid to moles, but obviously that is the unknown, and so I can't possibly go that way. That means I have to get to moles through the concentration of the base and the volume of the base. And remember that units of molarity are moles per liter, and so that's your in. That's the way that you're going to actually get to moles so that you can use the mole ratio. So again, I've sort of had this conversation online with a few of you over the past few days. You don't want to start with the molarity per se because those units are fractional. And usually any number that has fractional units, that's going to end up being a conversion factor within your solution. You're going to need that in a bit. But notice that here, the volume of the base that was used, that doesn't have fractional units. So that's probably your best starting point. So start by copying that over. 31.11 milliliters of the sodium hydroxide. Now the first thing I need to do is realize, well, this volume is in milliliters. I will eventually be using my molarity, which has units of liters in the denominator in its units, and so that means I'm going to have to convert these milliliters of sodium hydroxide to liters of sodium hydroxide first. And so again, there are 1,000 milliliters for every 1 liter of the sodium hydroxide. Now that I'm in units of liters, now I can go ahead and use this molarity. For every 1 liter of the sodium hydroxide, there are 0.206 moles of the sodium hydroxide. Now that I'm in units of moles, now I'm ready to use my mole ratio. And so basically, I need to relate the moles of the sodium hydroxide to the moles of the acid. Okay, notice for this particular equation, we have a 1-to-1 mole ratio. Now, once I'm here, I want to stop. And the reason I know I want to stop is because molar masses have units of grams per mole. I already have the grams part. That means if I just calculate this mole part for the lactic acid, I'll have everything I'll need to calculate my molar mass. And so I'm going to stop my dimensional analysis there and do this math that's in front of me. So that would be 31.11 divided by 1,000, and I'm going to multiply that by 0.206. That should give me, and I'm not going to round yet, 0.00640866 moles of the lactic acid. Now, to get the molar mass, I would have to take the mass of the lactic acid, 0.578 grams of it, and divide it by the number of moles I just calculated, 0.00640866 moles. Notice that my units will be grams per mole, which is what I would expect for a molar mass. So now I'm going to take 0.578, divide that by 0.00640866 moles, and what I get is 90.2 grams per mole. And those of you that actually went online and looked up the molar mass of lactic acid, you'll see this pretty much corresponds with the value that you looked up. So that's how you handled that type of problem on this particular set of exercises. Now let's have a look at number 2. For number 2, it's a slightly different problem. We're not being asked to find a molar mass here. We're told that I have 25 milliliters of nitric acid. That's going to be titrated with 0.12 molar sodium hydroxide. Now, you're going to completely neutralize 10 milliliters of the sodium hydroxide. All right, so to completely neutralize the acid, 10 milliliters of the sodium hydroxide must be added. They want the concentration of the acid. So, again, the mole ratio is key. You have to find a way to get to units of moles so that you can use the mole ratio. Now, notice that we have a couple of paths that look like might be reasonable, right? I've got the volume of the acid, I've got the concentration of the base, and I've got the volume of the base that was added. Now, again, I demonstrated this in the first problem. If I take the molarity, okay, which is again in units of moles per liter, and I multiply it by a volume in liters, I can get to moles. But if you notice, I don't have the concentration of the nitric acid, so I can't use this 25 milliliters of the nitric acid yet. I'm going to have to get to moles by using the molarity of the base and the volume of the base. And so that's where I'm going to begin. And again, since molarity has fractional units, like I've mentioned before, you're probably going to want to start with the 10 milliliters of the base first. So then that would be 10 milliliters of sodium hydroxide. Okay, and again, since molarity does have units of liters in the denominator, once again, I should be looking to convert these milliliters of sodium hydroxide to liters of sodium hydroxide. And once again, there are 1,000 milliliters for every liter. Now I'm ready to use my molarity of the base because I want to convert from liters of sodium hydroxide to moles of sodium hydroxide. So this molarity is given in the problem. It's 0.12 moles of the sodium hydroxide for every 1 liter of the sodium hydroxide. Okay, now I'm in moles. So now I'm ready to use the mole ratio. So then this would be moles of sodium hydroxide, and I want to convert to moles of the nitric acid. Okay, and again, the mole ratio would be 1 to 1 based on the balanced chemical equation. Now, again, the unknown in this problem is the concentration of the acid. And again, molar concentration has units of moles per liter. So that means I have to divide by the volume of the nitric acid that was provided. And so I'm going to show that by just multiplying by 1 over 25 milliliters of the nitric acid. But I'm not quite done there yet either because, again, these are milliliters and not liters. And so the last conversion I'm going to do is convert from milliliters of the nitric acid to liters of nitric acid. And there are 1,000 milliliters of nitric acid for every 1 liter. So if I do this math, then I should be okay. So I'm going to go ahead and take 10, divide by 1,000. Okay, this gets multiplied by 0.12, and then I'm going to divide by 25, and then multiply by 1,000. And if I do this math, I get 0.048 molar nitric acid as my concentration of acid. So use these first couple of solutions that I've put together as a model and go ahead and go back and try and rework these problems. I'll extend the deadline for this assignment one more day so you get a chance to practice it. Okay, so if you've already submitted the work, then go ahead and take that back and try this approach, and then go ahead and resubmit, and we'll see how you do with these problems then tomorrow. Okay, hope everyone's okay. Take care and stay safe. Talk to you soon.